Okay, Year 11. In today's lesson, we are continuing with our topic on natural hazards, and we're going to be looking at ways that we can reduce the risk of hazards. So in the last lesson, we were looking at why people chose to live in tectonic or hazardous areas, and we looked at things to do with farming, to do with money, to do with tourism, energy, resources, and family. And now we're going to look at ways that we can try and reduce the risks of the hazards for the people that have no choice or choose to live in these tectonic areas. So by the end of this lesson, we should be able to explain reasons why people continue to live in areas at risk from tectonic hazards, and to be able to understand and evaluate how monitoring, prediction, protection and planning can reduce the risks from a tectonic hazards. So please make sure that you have open the PDFs that we have whilst we're going through these activities, so you can do them at the same time as I am presenting this video. Okay then, so task 1, how can the risks from tectonic hazards be reduced? Well, there are 4 main management strategies for reducing the risks from tectonic hazards, and they are as follows. Monitoring. So when we monitor, we use scientific equipment to detect the warning signs of events such as a volcanic eruption. So it might be that they use thermal imaging to detect when heat is rising to the top of the earthquake, or of the volcano, or it might be seismometers, and they are allowed to measure any movement in the plate boundary. So they're ways that we can monitor so that we can be more prepared. The second way is prediction. So using historical evidence and also by using monitoring techniques, scientists can make predictions about when and where a tectonic hazard may happen. So by predicting them and using monitoring equipment to do that, we will be able to identify when or how likely an earthquake or a volcanic eruption is to occur, and then what we can do to reduce the impacts. So this is kind of what we've got here. So these are all the ways that we can monitor and predict. And we're going to look at this in a little bit more depth in the next task. The next one then is protection. So protection is to design buildings that will withstand tectonic hazards. And that's what we're going to look at in task 3. So what we do to make buildings earthquake resistant is what we're going to focus on. So we're going to annotate this diagram. And then the final bit is planning, so identifying and avoiding the most places at risk. So it might be that when they're building a new town or a new settlement, they put the buildings that are the most important away from the volcano, for example, which is what we have here. So the red zone is a zone that's the most dangerous. The blue zone is still quite dangerous, but not as, so you would have buildings there that are kind of medium priority. And then the yellow zone is a zone that is safer, and therefore you can build further away. Okay then, so task 2. What can we do to monitor and predict hazards? So there's 4 ways that we can monitor and predict hazards. So we've got seismometers, spiders, thermal imaging, and tilt meters. So these 4 examples allow scientists to make accurate predictions about volcanic eruptions and earthquakes that are taking place. So hopefully these will reduce the risks. So what are these things? So we've got 8 statements here. 4 of the statements are giving a description of what these monitoring and prediction strategies are, and then 4 other statements are giving us examples. Okay then, so what is a seismometer? A seismometer is used to measure earthquakes occurring near an eruption. So this is our statement here. So basically, when an earthquake is about to occur, there's lots of tension building up between two plate boundaries, so the plates will start to move. So basically, this seismometer, you can see, it kind of looks as if the thing you get in a hospital to measure your heart rate. The line should be quite consistent, so it should kind of stay like this. Now, if there's any movement in the plates, then the lines will start to increase and move. So that allows us to detect if an earthquake is about to happen. So do we have an example of where this happened? Well, prior to the 2004 eruption in Mount St. Helens, seismometers were able to detect earthquake activity. So they were able to identify. So because they could see that these lines were starting to go more like this, they then were able to use different techniques to double check. So they used multiple different scientific equipment to identify that an earthquake and then possibly a volcanic eruption was about to happen. So the next one then is a spider. So spiders are robots, and what their purpose is to monitor the gases escaping from volcanoes. So these are to do with volcanoes, and these are spiders. So that's what we can see here, these little robots, and they are able to detect any changes in the gases in the atmosphere. So if there was a certain amount of a different type of gas, like sulfur dioxide in the atmosphere, then that might be because possibly the volcano is about to erupt. So that's not much of a prediction, that's more of a monitoring. It's about to happen, and therefore they maybe need to get away from this. So where did this happen that allowed them to be able to predict and protect the amount of people that were possibly injured? Well, in 2009, scientists were able to use spiders to detect the release of gases. However, it wasn't as accurate because there were lots of clouds in the atmosphere at this time, which meant that the data was not as reliable. So spiders are only really reliable if there's a clear atmosphere, and also if they can use it maybe with an additional thing such as a thermal image, which we're going to move on to next. So thermal imaging is when we use colour and maps to detect heat around a volcano. So you can see here that that uses a key. So if the colour is like a yellowy reddy colour, it suggests that it's just normal, there's no heat within that. And the closer it gets to being purple, it means that it's very, very hot, and it means that there might be magma trying to escape through the volcano, which you can see in this image. So this is this one here, thermal imaging. And it's using temperatures and heat to detect heat around a volcano. So where was this happening then? Well, similarly in Mount St. Helens, helicopters had thermal infrared cameras on them that allowed them to identify that there was heat starting to rise up through the volcano, which means that it was about to escape. Similarly, they would be able to go around the whole perimeter of the volcano to identify where that magma might be able to escape. So if I just quickly draw a volcano here, so if it was purple on this side and then it was a reddy yellow colour on this side, then this suggests that you might need to evacuate people that live on like the east side of the volcano as opposed to the west side of the volcano. So that's another way why thermal imaging is really good at monitoring and predicting hazards. And then the final one is the tilt meter. And this allows us to identify any changes in the landscape of the volcano before it's about to erupt. So if we look here at the image, or if I draw a little image for you, if there was a volcano about to erupt and it was coming from the the east side, it might gain a little swell. So that swelling could be that magma is building up within it, and then that would escape. So this is really important for identifying changes in the volcano. And this was really important during the Mount St. Helens volcano in 1980. So basically, by using tilt meters, they were able to identify swelling before the volcanic eruption, and that's what we can see here. This circle shows that swelling. And that meant that they could try and remove people away from that side of the volcano so that there were less deaths. Now, obviously, by the time of tilt meter, it's quite late on, so it might not be that helpful because it could be about to erupt, and therefore you're less likely to be able to put systems in place that removes people from that area. So let's move on then to task 3. Task 3, you need to watch a video. So this video is looking at ways that we can protect our buildings by constructing them to be earthquake resistant. So on the PDF that I've given you, there is a link to that video. I've also embedded the video so you can watch it through that. And whilst you're watching the video, you should be trying to annotate an image, this image here, which you can see in the top right hand corner. So you should be annotating this image to look at ways that the things that they do to buildings to make them earthquake resistant. So make sure then that you've got all of these things down. So some things that we can identify is that they have a safe open areas for people to gather. So places where things aren't likely, so buildings or infrastructure isn't likely to collapse on them, so they're safe from infrastructure collapsing. So this will reduce the amount of deaths. They have this lattice steelwork, so this steelwork is going to be much more secure than steelwork that looks like this. So by making this a very these strong foundations, that will mean that the building is more secure and then less likely to collapse. They also have rubber, so they're using a variety of different materials to try and solidify and strengthen this building. And then they also have rolling weights on the roof. So if basically what this does, so they are computer controlled, and what they try and do is that if the building starts to sway, the weights move in the opposite direction. So if the building was moving in this direction, so if I build a little thing, if it started to sway in this direction, the weight would move in that direction to try and move it back, and vice versa. So it's trying to act as a counterbalance. So that's a really good word that you could write down. So the rolling weights act as a counterbalance to keep the building steady. They've also added on other things here. So this doesn't protect the building from collapsing, but if there are any injuries or people are needing help, by putting numbers on the top of the buildings, it makes it easier for helicopters or search and rescue to identify what building they're going to. And then there's other little things as well. So make sure you have all of these examples round your diagram. And if there's any you're still not sure of, you might want to do some little bit more research, or you can send me a message. Task 4 then is a practice question. Now, I don't want you to answer the full practice question, but I would like you to have a go at planning it. So let's go through what the question actually wants us to do. So it says, evaluate the usefulness of planning and preparation in reducing the effects of an earthquake. So, evaluate means you have to talk about why it's good and why it's bad. So we're saying how good are planning and preparation at reducing the effects of earthquakes. So we're trying to reduce deaths. We're trying to reduce injuries. We're trying to reduce damage. And we're talking about earthquakes, not volcanoes. So you might want to write an introduction about the different ways that you can help predict and protect against earthquakes. So you'd have a little introduction and you would just identify the different strategies you're going to talk about. You might have one paragraph talking about planning. So your planning, you could talk about the earthquake resistant buildings. You could talk about evacuation drills. Similarly to when we have fire drills, so we know what to do. We could talk about the hazard maps, so building more important buildings further away from the volcano or the earthquake. Sorry, well, it wouldn't be from the earthquake, it would be from like where the plate boundaries are. So hazard maps allow us to identify where are the safer regions. You can think about it when we did rivers and coasts, and you know, when you're thinking about where you put important buildings in relation to the river, you build them further away, and you build the less important buildings such as like farmland, car parks, open spaces closer to the river, because the effects of that would be less than they would be if it was to flood a hospital or a school. And then you would write another paragraph talking about preparation. So how could they be prepared? Well, they could rely on seismometers. So that would allow them to identify if an earthquake was about to happen. They could have evacuation sensors. Okay. And you might want to actually make reference to the Nepal and the Italy case study that you learned about a couple of weeks ago. So you might want to talk about things that they had in place that meant that the impacts weren't as bad as they would have been if they didn't have those things in place. So remember that this is an evaluate question. So when you're talking about all these examples, you need to say why they were good and why they were bad. And then in your conclusion, you might want to identify whether you think planning or preparation was better. So in your conclusion, which is better and why? Okay, so remember that this is just a plan. So you might want to just beef up what I've already said, and that will be enough. If you have any questions, please send me a message on It's Learning, and I hope you find this video helpful.